And so you're going to end up with a pyramid with a lot of electrons up here, and then not very many electrons. So then you end up with a very strong negative charge, very strong positive charge. Okay? Or partial positive and partial negative, since these are not full charges. Oh, shoot, I wrote polar under geometry. So it's polar, yes, but the geometry, which we should have done first, is trigonal pyramidal. Or just pyramidal, I think. Pyramidal should be fine because it's a pyramid. But trigonal pyramidal is more specific as to what kind of pyramid it is. And so this geometry comes from the fact that we have this one lone pair. So check your geometries again. You have one lone pair up here, and that's going to push all of those iodines down. And that's going to push them into that shape. That's a pyramid. Okay? So that is Ni3. Just going to draw a line right there. All right. Let's do CO2. Okay, so CO2 has 4, and then oxygen's in 6. So we're going to have 12 plus 4. So that means we're going to have 16, right? So 16 electrons. I mean, there's only 3 atoms, so you can kind of imagine what's going to be in the center. Carbon's going to be in the center. We'll draw out with one bond going to oxygen, like this. Okay? And we have our 16 electrons. So now let's add those 16 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Great. So we've added all of our electrons, but we have a really big problem. And that is that this does not follow the octet rule. So the octet rule is telling us that we actually need to have an octet for everything. And this carbon here does not have an octet. It just has 2 electrons here. Or rather 4, right? Because it's sharing all these. But it doesn't have 8. So it needs 8, but it only has 4. So the way that we fix that, and because we've already distributed all of our electrons, we can't just add more. The way we fix that is we actually bring in an electron into there. Okay? And then we end up with CO2. Okay, so we bring in that whole pair. And that whole pair is going to form another double bond. And this would also be a good time to mention what these guys are. So this we said, the first bond we said was a sigma bond, right? The second bond that forms is a pi bond, okay? And a pi bond comes from a p orbital interaction, all right? And this comes from actual overlap, but that might be beyond the scope of what we're talking about here. So sigma bond is that first bond. It's a single bond, and then the pi bond is the second bond. But you always have a sigma bond. The sigma bond is the sharing bond, and the pi bond is the double bond, which is just an interaction. So if we look at the geometry of this one, shift this up a little bit. If we look at the geometry of this one, it's going to be linear. Because we have both of these double bonds here, it's going to basically just be a straight line. You can also consult your table, or your there are no lone pairs, so you can consult your chart and see that. Linear geometry, polar? No, actually, this is not polar because the oxygens are pulling on that carbon with basically the same strength. It's the same atom with the same bond, so it's going to be pulling on that carbon with the same strength, so they're going to cancel. So this one, it'll be like a tug of war with people that have equal strength. Okay, so that's CO2, and that's the double bond business too. I think that one might have been a little bit confusing. Let's do HCN. So this is hydrogen cyanide, which is very toxic, so don't be breathing that shit in. I'm not sure if I'm allowed to say that, actually. So for carbon, nitrogen is 5, and hydrogen is 1. So that's 10, which is a pretty easy calculation. Now, hydrogen can only form 1 bond, and nitrogen can technically, I guess, form 2, but it would be more reasonable to say that the carbon is, because carbon's been at the center of most of the atoms most of the molecules we've been working with. So if we put carbon at the center, put nitrogen here, put hydrogen there, put our single bonds, and then we distribute our electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogen has 2 electrons, so it doesn't need any more. So this is it. We're done. Now the problem still, again, with this problem is that the carbon does not have a full octet. So we have to bring in a lone pair. So then we get this. The problem is with this is that we still don't have an octet. This is still only 6 electrons, so we have to actually bring in 1 more. And so what this is going to lead to, I'm just going to do that right here. So what this is going to lead to is a triple bond and 1 lone pair there. Okay? And so this has 1 sigma bond and 2 pi bonds. Each double bond that you add, or each single double bond that you add, which is kind of confusing, is a pi bond. So this is 1 sigma, which is the initial single bond, and 2 pi bonds for this bond. This is just a sigma bond right here. Okay. Geometry, it's linear. Same thing as the other one. Is it polar? Yes, I think I would say that it is polar. These are not the same atom. Hydrogen, nitrogen are not the same. Nitrogen is electronegative. It's pretty electronegative. So I would say that there is a dipole, and it's probably going to have the electrons on the nitrogen. So we're going to have a partial negative charge there. Sorry, that's kind of crammed in there. We're going to have a partial positive here and partial negative. Okay. So that is Lewis dot, polarity, it's quantum numbers, electron configuration, electronegativity, radii ionization energy. Hopefully that should get you prepared for your exam. I think you're all going to do great. I hope things at home are going okay. Please let me know if you have other questions. I can try and answer them this weekend. So good luck, and I will hopefully hear from you all soon. Have a good rest of your semester.